Year 11. Welcome to the brave new world of online learning. This week's content and a bit into next week is all to do with simple and compound interest. These are topics that are actually moderately relevant to life. If you ever lend someone money, or you borrow money, or you invest in savings, interest matters. So you can look at interest from two perspectives. One is savings. You have some money, you want to make some more money. You want to invest that somewhere. You want to make money off your money. In that situation, you earn interest. The interest is the additional money you get. Examples of that are things like term deposits, where a bank holds your money for a certain amount of time and pays you a certain amount of interest at the end of it. You're not going to get much at the moment. Interest rates are incredibly historically low right now. But normally that wasn't a terrible way to go. And then of course the other way of looking at interest is when you borrow money, you need to pay interest. So, banks don't give you money for free. They expect you to pay something to have that loan, have that car loan, have that home loan, have that credit card. Don't get a credit card. And you pay interest in those situations. So there are two main types of interest that exist out there and that we will deal with in this unit. One of them is called simple interest and one of them is called compound interest, hence the surprisingly appropriate diagram sitting here. So simple interest is always essentially calculated off the original amount. So if you invested $2,000, simple interest would always be calculated off that $2,000. No matter how long you've invested it for, you're just going to get it calculated off the original amount. All right? Compound interest is calculated off what I'll call the current amount. So if you invest $2,000, you might get a little bit of money at the end of the first year. Well, your interest for the second year will be calculated off the amount you have at that time. In other words, you earn interest on top of interest. So if I had $2,000 and at the end of the first year, let's say 10%, if I got 10% on top of that, I'd have $2,200 at the end of the first year. The interest for the next year would be calculated on the $2,200, not the original amount. So compound interest applies on top of whatever your value is at any moment in time. You earn interest on top of interest. If you graph it, you end up with interesting relationships. If you graph simple interest, it always creates a straight line. The amount of money you're going to get is going to keep going up by a fixed amount. But compound interest, because you're earning the interest on top of interest, it ends up looking like an exponential function, which is quite a topic at the moment. If you notice the trajectory of coronavirus infections in countries that didn't take decisive action, it's also an exponential model. Now, from here, the first few lessons that I'm going to go through, the nominal ones for Monday and Tuesday, are on simple interest. And the ones for Thursday, Friday are on compound, and then there's these sections comparing simple and compound. So essentially, this is what we're at today. But I'm giving you a little bit of insight into where we're going after this point. Now, simple interest, the annoying thing to note about simple interest here is that the formula used in the textbook and the one that's on the formula sheet, you actually get a formula sheet when you do tests in essential mathematics, if we ever end up physically together in the room doing a test. And that formula is different to what you did in your earlier years. And I've got to stop saying it's really an annoying habit. Sorry about that. In the past, you've seen simple interest calculated by this formula. I equals PRT over 100. Or you should have. Hopefully you had a teacher that did, do what you were meant to do in previous years. It's different being able to have tea and teach at the same time. Anyway, your book has a slightly different formula, and I haven't really used it much. Are you scared? All right, it looks like I equals PIN. I want to get it exactly the same, guys. It is actually the same formula, which you're probably not believing right now, but the difference is actually here. In your old simple interest formula, the interest rate was a percentage, but in the formula we're using now, there's a little I instead. And this is actually your interest rate as a decimal. So in the old formula, it had this divided by 100. That divided by 100 was essentially turning that percentage interest rate into a decimal, while the formula over here just assumes you've got a decimal to start with. Now, the reason I've decided that I'm going to do our examples using the same terminology and symbols as the book, because I don't want confusion between the two different ways. But if you happen to be remarkably comfortable with that, I can only presume it's because you're in my Year 10 class, then you can do that. That's okay. You can use that formula, you can modify that formula, you can use it all you want. But as the text uses this, I'm going to focus on this in our materials here. Now, probably worth pointing out what on earth each bit there actually is. All I can hear is birds in the background. It's really a bit different. I is interest as a dollar amount. This formula, essentially, as it reads, would calculate how much interest you're earning as a dollar amount. Now, P is the principal, which is the initial amount, and that's also a dollar value. Right? That's how much you started with. You invested $4,000, or you started off with a $4,000 debt to the mafia. It's what you're starting with. Right? I is interest rate. As discussed above, it is in the form of a decimal. And N is your number of time units. As the questions get harder, the most common error we see is consistency between the time units used. So I'll inevitably give an example of that later in the lesson, but make sure you are consistent. What I mean by that is you're either working in years or months or any other unit. You could even use hours, minutes, or seconds if you wanted. But that interest rate, if you're using years, that interest rate should be per year. If you're using years, interest rate per year and time units per year. If you were using months, if you're working in months, then your interest rate would be for 1 month. Your time units would then be number of months. Make sure you are working in a consistent time unit. All right? So, with all that aside, we probably about time for some examples. You gonna do some examples? Okay, don't get too excited. Here we go. This is a very small board. My daughter is going to be entirely ropeable that I'm using it too. Maybe we can get that on video, it'd be pretty funny. Anyway, I'm going to have to make up names because this is all public and I don't think I can talk about students' names. So, okay, I'm going to start with Barry. Barry's going to borrow some money. Barry borrows $8,500 at 6.4%, that's per annum. Normally when interest rates are quoted, they're per year, which is the same as per annum. So it's 6.4% per year in effect. Right? I should have said simple interest there. That was naughty. For 4 years. How much will he have to pay? How much? Well, we'll do this in parts. How much interest will he pay? So let's think about what we've got there. There's some weird number up here. What is it? It's P, it's the principal, right? That's what he's starting with, 8,500. What else do we need? This is a simple interest formula. I, the interest rate, we need it as a decimal. To convert a percentage to a decimal, we divide by 100. So it'll be 6.4 divided by 100. You can put it in the formula like that if you want. You don't actually have to calculate that. You could just put it straight in the formula, it'll be fine. And N, now that was interest rate for a year, and we have 4 years, so we're working in years, it's all good. As long as we're consistent, everything's in years, we're good. So it's 4 years, N is 4. Now, as always here, I expect that you do your working properly. By doing your working properly, I expect to see the formula. I expect to see I equals PIN, our simple interest formula. Then I expect to see the values substituted in. So 8,500 times 6.4 over 100 times 4. Need a calculator. I have something very special today. I have a Japanese import. This is the best scientific calculator. Well, let me check that out. Yeah. Now we go 8,500 times 6.4 over 100 times 4. And make sure to include units. It's saying 2176. At this point, it's probably useful to remember what this formula actually calculates, which is the amount of interest. So that there is, therefore, the interest earned is $2,176. Right, now, from there, you may be asked things like, how much does Barry pay in total? So Barry not only has to pay that $8,500 that he owes, he now needs to pay this interest as well. So we just add them together, right? You may have seen it before, A equals P plus I. I'm pretty sure I've shown that in my class. The total amount he has to pay is the amount he borrowed plus the interest he's earning on it. So that should be 10,676, I believe. That work? No one to check it on a calculator for me. I could be making terrible mistakes. No, this one isn't. All right, another thing you could be asked is, how much would Barry pay if repaying monthly? Right, so in this case, the repayment is going to be his debt, well, the total debt, divided by the number of months. So the total debt was 10,676, and it was over 4 years, how many months are in 4 years? Well, let's start with how many months are in a year. There's 12 months in a year. So over 4 years, it'll be 4 times 12. You could have just written that as 48, I don't mind. But yeah, 4 years, there's 12 months in a year. That's how many months there is. So we put that in the calculator. And 10,676 over 48. And it's approximately, we have to round it here, $222.42. Remember to do the rounding to the second decimal place. We always round to the nearest cent per month. So there we go. That covers a few different types of examples. There are more examples. I will send you the text chapter here, but we're actually in the year 12 text now for this content. Okay, that's fine. We've introduced you that, the idea of the total amount. I may even put a marker, there we go. I'm just going to call that total amount, A for amount, is principal plus interest. Okay, so we've done those sort of questions. You could be given questions where you have to make choices between different investments. That's in the text. And then we've got to do ones where you need to rearrange the formula, which everyone always enjoys a lot. What I'm probably going to do is do a question here that doesn't involve working in years. So I'm going to do a more complicated example involving not working in years, and then I'm going to do a question where we need to rearrange the formulas, because we do need to discuss how to rearrange our wonderful simple interest formula. It's not too bad, but we do need to get it right. So I hope you've got that down, because I'm about to knock it all off. All right. I'm going to try to keep these down to under half an hour each, if possible. Actually, I can see some very bad news on here. It is telling me that I am not going to be able to fit this on my phone.